So guys, welcome back to the YouTube channel, and today we're bringing you part 2 of our networks video. So we're going to be going over the switches, some of the questions you guys asked in the last video, and then we're actually going to show you some of the switch configurations that we're going to write to the 2 switches we installed in episode 1 and show you what they're doing, how they're doing it and why. So stay tuned, roll that intro.
Okay, so we have a few questions from our previous video which we would like to answer for you before we kick it off. So I have one from Tuna Fish and one from DTech30 asking what the blue cables between the 2 switches were, and that's so that we can connect the switches together. So if one of the internet feeds went off, then the other switch would still have connectivity down the other feed. And that's all it's there for, really. And there's 2 of them just in case one port failed or someone decided to go at it with a pair of scissors. You've got a little bit more resiliency there. So we'll be putting those into a port channel and making sure that spanning tree is set up properly, which is hopefully what will happen in this video. And then I have another one here from I think that says Liban, and it asks the switch ports are facing the back of the rack door. Is it meant that the ports exhaust air at the back? And if not, the hot air will be going to the cold aisle, which is a waste of cooling power. The exhaust from the 2960s that we put in, it does go out the back of the switch, and their fresh air intake is from the sides. So they're always going to be taking in some warm air regardless, unless you do some very clever blanking. And with regards to wasting the air and the efficiency of it, we have blanking in the front of the racks, so no hot air can actually get into the cold aisle, so it will just circulate round. With those ones, there's not really a good way of putting them in unless you spend a lot of time blanking them out properly. And then the Cisco 2960G is a single power supply feed only. Is there better practice to install an STS or an ATS and connect the power to it to have redundancy? So yes, it does only have a single power supply, but there are ways to get around this. I have some things on the table here. So this one is a Cisco RPS, and you can see it has ports at the front, which we connect a DC cable to, which goes into the back of the switch. And then on the back of the RPS there are 2 power inputs. So this means that if the power went out to the first feed on the switch, it would then run off of this unit. The only downside with an RPS is if that happens, you then have to reload the switch to switch back to the internal power supply of the switch. And then the other option is actually just to buy a switch with 2 power supplies. And I have an example here, which is a 3750, and this guy has 2 power supplies at the back that are removable. There's one there, yeah, and then there's one there as well, so that would be a better solution. I'm not going to go into it now, but sometimes it's better to not use an ATS or an STS, specifically for us, of the way that we deliver the power. But that, like, if you wanted that explained, that's like a completely different video.
A long video.
So it's not necessarily always the best case. I'd always go for a dual power supply, or just accept the fact that your switch might turn off, so you have more than one. I think that's my questions done.
Cool. I've got some. So, Mode Tyab, I believe. Sorry if I mispronounced that. I'm happy to see you after a long time, and we're happy to be back making content for you guys. Please tell in the next video, what are the basic skills for a network engineer? Now, it all depends on where you're working. Here, we have different requirements to if you worked, say, at another data center. I'm not going to name other data centers. The requirements here are different to what you'd expect at another data center. Other data centers might require you to have all sorts of networking qualifications, yada yada yada, but we don't require any of that. We do have people who do have the network qualifications that are in the network team, but on our team we don't have them because we don't really get involved too much with the network side of things, purely because that's what we've got a network team for. That's what they're here for. So if you were going for a network engineer role, for us it's not a requirement, like CCNA for instance, it's not a requirement, purely because what you're taught in CCNA is not how it's done in the real world, but that's my opinion. So yeah, it really depends on where you work, what role you're going in to do, what your expectations are. But I wouldn't worry too much about qualifications unless you're specifically required to have them for whatever you're doing in your career. So, where are we? Chit chat. Just curious, is there an advantage for having several smaller pods versus large pods encompassing everything? Is it easier to locate cabinets? It is easier to locate cabinets, but that is not their purpose. So the reason we have smaller pods is, firstly, security. If you've got a massive data floor with 100 racks in, that's 100 potential customers that could have access, not access to your rack, but they can touch your rack. Whereas in a small pod like what we've got in data floor 4, only the people in that pod can get in that pod, which means the number of people that can physically touch your rack is reduced. Doesn't mean that someone's not going to go in and poke something through the front of the rack, but people don't do that. They just don't. It also helps with cooling. So we can control cooling on a per pod basis. So certain pods downstairs have different equipment in them. We've got one pod that's got a lot higher power equipment. You've probably seen in our video or heard in our videos when you go into the lobby, there's a really loud noise. That's just one pod, 4 racks in one pod, which does require more cooling. So we cool that pod differently to the other 3, and the extracts are different. You know, it's a balance for the cooling side of it. And it's also good for fire suppression. It's good for power delivery, monitor. There's just there's a whole heap of benefits to it. So yeah, I'm not going to go too much into that. That'll be for another video anyway. And the final question, and I do apologise if I pronounce this wrong, Yashwanth Simhadri, maybe. Sorry if that was wrong. STP is used for loop prevention. I think you mean HSRP. Correct me if I'm wrong, please. No, you're right. I was wrong. I got my terminology muddled up because I see it from an ISP side and we're demonstrating a customer side, so I'm in a different mindset to what a customer would be. Sometimes I do use the wrong phrases, but in my head I know what I mean and what I'm expecting to happen. But yes, you are correct. So I suppose we'll go and do the last bits in the DC and then get configuring.
Yep.
Yeah, perfect. All right. We'll see you guys in the DC.
Okay, so I think we should probably just quickly address a few comments that I know that we had about the equipment that we're using. We are using these 2960s in the videos. And so we're using these because the idea of this is that everyone at home can follow along. So if you wanted to actually go out and buy one, it's not going to cost you the earth to go and do it. In the real world example, you would probably go and actually go out and buy something that was new that had a service contract, but obviously we're doing this so that everyone at home can follow along and the concepts are the same regardless of whether it's new or old. So yeah, we're not actually using them in production.
No, rest assured the kit we use in production is very, very new and very supported and under all sorts of support contracts and warranties because it's very critical infrastructure. So, as James says, this is just for the purpose of doing YouTube videos. What we use in production, we can't say what we use, but what we've got in production is not this stuff. So, yeah. Thanks for understanding. Okay, so powered up the switches in the last video. Today we're going to be connecting the console cables, which will allow us to remotely configure the switches. We're going to plug the console cables into a laptop and then we're going to remote onto the laptop to configure it on a local serial connection. So I've got 2 console cables here, like so, and they've just got USB interfaces on them so I can plug them into my laptop. So what I'm going to do is I'm going to take the RJ45 end, which will be connected to the back of the switch, I've got James around the back waiting for the console cables. Okay, so now we're going to plug these into the laptop. So I'm going to come around here, plug one in there and one in here. Open it up. Okay, so what I'm literally just going to do is I'm going to get TeamViewer loaded up and I'm going to take a photo of the credentials and then we'll go back up to NOC, connect to it and start configuring.
Okay, so we're about to start configuring these two switches that we just saw in the data center and in the previous video. When I was checking these over before we actually got into this, I noticed that a few of the ports aren't actually working. So that's sometimes what you get when you buy lab equipment off the internet. Not everything works sometimes, so I've had to change the port numbers for the cables that we've plugged in, but I'll explain that as I go through, so just the numbers aren't the same, but it's fine. So you should be able to see on my screen now, I have the two devices connected here. First thing to do is go into enable mode so that we can actually run some commands on the unit. If we do this one here, the show interface description, we can see all of the interfaces that are connected. You can see I already have a port channel here, which is the one that we're going to be using in the video, and then there's also here as well. So we'll be able to use that, or we can create a new one, doesn't matter really. And then we have ports 41 and 42 are our new blue cables that we're using. So first thing to do is to check those and what they actually have configured for them. So if you do a show run interface and select the interface, which was 41, we can see what its current configuration is, which is basically nothing. And you can do the same for the other one as well, except for this one. This one has actually been told to shut down, whereas if you plug something into this one it would come up in its current state, but that's fine. The switches are blank, so there's not really anything going on. They'd already been reset. So the first thing to do then is just to make sure that spanning tree is on and configured. So we can see what it's doing at the moment. If you do show spanning tree summary, you can see what spanning tree currently is doing. And we can use this later on to see if spanning tree is actually working. So if we go into configure mode, so you go configure terminal like this, and then you can do spanning tree mode, and we're going to use the rapid one, which is a bit faster, so we're just going to tell it to use that. And then we're going to set the priority on the VLAN, which is what we'll be using between the switches and the two uplinks that we have. So let's make sure that's also done on the other side as well. Have you noticed I'm typing part of the word and then I'm pressing tab, and then that's what completes the words. Otherwise you can do things like actually that doesn't matter. Otherwise you'd have to do the whole word, but you can do like show run. Instead of typing show, you can type parts of the words. Just a little thing there. And then next thing is we want to set a VLAN. So I'm going to set a VLAN for our incoming connection that we're going to be using. So if we do say interface VLAN 2, we'll give him the description of internet for now. It doesn't need to be anything cool. And then we can come out of that and we'll do the same on the other one. internet. Okay, and then we're going to give him a span entry value. So what we really want to do is we want, for us, custodian, to have span entry controlled by the routers that we're connecting the customers to. So we make sure that the customers use a higher span entry value so that we're the ones that are doing the span entry. So in that case, then we have to set the span entry value. So you can do spanning tree VLAN 2. We set the priority as a high number. In this case, I'm just going to go with 57344. And then that means then the lower value will take over and control what port is blocking where. And then we're just going to do the same on the other one. So they both now have a high value. If you want, you can do you can see if span entry is doing anything at the moment, although it won't be. But you could do and then see nothing really has changed, but that's fine. Next thing for us to do is to configure our port channel between the two switches. So we have span entry enabled, so now we can't loop them, which is good. We can set a port channel. So we want to do interface port. Come on. Oh, it's just because I can't type. Face port channel 2. And we can give them a description of, we'll just call him switch to switch, PO2. And normally you'd probably want these in a trunk, to be fair. So you could do you can make him a trunk. Oh, can't type. So what I've done there is I'm allowing VLANs in the trunk, but only VLANs 1 to 50, and anything else won't pass. We'll make sure it's not shut, and then for now, that'll be it, and then we do the same on the other side as well. Okay, so they're both the same again, and we can come out of that. So the next thing then is we actually need to configure our interfaces and attach them to the port channel. So we select the interface, do interface GI041, and you can do both as well actually. Being as we've got two, we can put them into a range. So you can do interface range GI041 to 42. So now what that means is any configuration changes we make, it will apply it to more than one interface, the ones in our range. So we're not having to type as much, which is a plus. So we can go with so basically it has to have the same, more or less the same config as the port channel because they're going to be joined together. Triangle allow VLAN 1 to 50. We can give them a description of, so this is switch to switch PO2. Link 1. This, to be fair, this isn't how I'd normally name all the interfaces, but for this we know what's what. And that's fine, and then you'd also want to put it into the port channel. So you select the channel by doing channel group 2. Oh, sorry, I missed a bit. Mode active. Right, so now there are different modes, and then there's a list of what the different modes do on the Cisco. So we're using channel group mode active because it uses LACP, and that's the kind of technology we're wanting to use in our case between the two switches. There are other ones which you can find on the Cisco website. So let's do the same on the other switch. Okay, and then we might as well no shut the interfaces now, so that should bring them up on both sides, hopefully. So you can see they went changed state to down, they've gone to up. Spanning tree is kicked in. It's found the root bridge and the port channel is up. And then if we come out of this, we'll set our descriptions properly. What did I set it as before? Switch to switch, PO2, that was it. Link 1. You can select an interface while you're already in an interface configuration. You don't have to back out and go back in again every time. Let's just copy paste that. So now if we have a look at what the interfaces are doing, if you do a you can see that our two interfaces that we've configured are up, and so is our port channel 2. And then you'll see again, if we do that on the other side, you can see both ports are up, port channel is up. So we now have a working link between the two switches in a port channel. So if I went and pulled out one of those cables, the port channel should still work. So let's test that while we're here. Let's have a go. If we select one of the interfaces. That's because I've done O instead of 042. Oh. So you can see the port went down, but if we do you can see that although we've got one cable that's now no longer working, our port channel is still up, so there's still connectivity between the two. If I bring it back, the interface changes, goes down before it comes back up, port comes back up, and then he's working back in the port channel. Now you'd have 2 gig between the two switches. And you can see every time I do that, spanning tree is doing its thing and it's working out its thing to make sure there are no loops. So, I feel like I've missed something, but I don't know what it is. So let's come out of configure mode for a moment. We can have a look at what spanning tree is doing. If we do that show spanning tree summary, we can see what VLANs there are, 3 VLANs, who's active and what's in it, and then there are also more commands to see what VLAN is doing what. I believe you can select the VLAN 2 and you could do, say, a summary of that, and you can see exactly what what VLAN is doing what in what spanning tree, if that makes sense. Lots of what's in that sentence. There we go. And you can see the VLAN 1 is the root bridge, and I bet if you do the same on the other switch, it should say something different. And then you can see that VLAN 1, the root bridge, is this MAC address. So that's telling me that the MAC, which is this guy here, that this guy is controlling the spanning tree and this guy isn't. So a little bit of useful things there for you to see what spanning tree is actually doing. Okay, last thing for us to do is to actually configure the two interfaces for our incoming internet feeds, and I've stuck them on two other ports. So I think, I don't remember 100% what I did. I used port 44. So if we go back into configure mode, we select the interface, we do switch port mode access. Because it's not a trunk, we're only getting one VLAN from us, and it's untagged or a VLAN 1 that we're sending to the customers normally, unless you've asked for a very specific service. So we always use switch port mode access, and then we tell it which VLAN it's using. So we're using access VLAN 2 for our internet. We're going to give it a no shut to make sure it's there. We know it's now the internet because it's given us a description. And that's it. And then if we come on to the other side, we do the same on the other side again. Oh. Okay, cool. So I've configured the next interface for the internet. We've put in access VLAN 2. You can see I didn't actually already have VLAN 2 on the switch on this one for some reason. Maybe I missed that out and I just forgot. But you can see spanning tree has done its thing. And we're going to give him a description of internet again. And make sure he's not shut. So the next thing is for the provider, which is us in this case, to actually unshut the ports on the other side. So I do need to get up and go to my desk and actually unshut them. So we'll catch you in a few minutes. Okay, so I've just gone and enabled the 2 ports on our edge layer. So now, hopefully, the ports will come up and we can see spanning tree working properly. So let's have a look at that. If we do, we just have a look at what everything is at the moment, what ports are up. You can see that our internet port is up here. Our port channel is still up, which is good. And then if we do the same on the other side, again our internet port is up and our port channel is up, so that's all good. So now let's have a look, see what VLAN 2 is doing. So if we do show spanning tree VLAN 2, we can see that port 44 is the root, and then if you do it on the other side as well, you can do, we can see that the root in this case is PO2. So essentially what's happening here is the root is our router, and then goes to this switch, and then for the other switch it's getting it from its connection from the other switch over the port channel back to our router, so it's kind of in a line. And that is it. I bet, actually, while I'm here, because I'm connected to the console, I can shut the root on this, and spanning tree should do its thing and it should swap over. So I'll tell you what, let's try that. So if we go into here, and we just shut the current root port, in theory we should see a load of spanning tree events. And then we can see spanning tree has changed. The port is down on our other switch here. The new root bridge is on port 44. And then if we have a look at the spanning tree again, we can see that port channel 2 is the root. Obviously the port isn't there at the moment because it's shut. And then the same on this side. You can see that now port 44 is the root. So it works. So our spanning tree is all happy. And then let's just put him back, and then you'll get the same events again. As the line comes back up. So that in a way is kind of like simulating a link failure. So we never lost connection when we shut and unshut the ports. Our spanning tree is working properly. We don't have any loops. If we did have loops, we'd have a ton of events, so not good. And then that's it. Obviously there are more in-depth videos on how all of this, what I did here, actually works. So this is by no means one of those in-depth videos, but it does give you a good idea of how everything works from a basic level without going like really in-depth and spending 30 minutes on how VLANs or port channels work. So hopefully you guys enjoyed that. Let us know if I actually missed something or I should have done something different. I'm sure you will down in the comments. And we'll see you in the next one.
So guys, I've kind of left James to get up to his own devices with the switches. He's doing some more config stuff just because he's a little bored at the minute. So while James is doing that, I'm going to say goodbye to you lovely people. Stay tuned because the next episode of this series, we're going to be doing some troubleshooting, and we're also going to be showing you how we monitor it with syslog, and how we actually report on various events that happen and how we deal with them when they come in, such as random ports going down and stuff like that. So remember to hit the like button, follow the channel, and leave comments on what you want to see in the next videos, and we'll do our best to accommodate it. See you next time.